Hello. So, been a while. I wanted to show a bit more of what I've done on the Subleq assembler. And basically, the goal here was to have better uh, error handling. And I decided to focus on that apparently instead of actually doing something like tokenizing or something. But first, let me show you a few changes that I made to the files that I showed in the last video. I think there's going to need to be some changes to file names. These might have to be interned, but I'll need to uh, work on that another time, and I'll show why I'm thinking that later. But it's mostly just changes to the documentation, some function names. This was actually a while ago. I added these derives. I don't quite remember everything that I did, but I know there was some documentation changes, function name changes, and yeah. I think this will need to become generic, but I'll show why in a bit. So this is the new Subleq lints crate under the workspace, and first thing we have lint severity. So we have error, warning, note, and allow. My plan is that notes will not appear as compiler output unless you use a special flag or something. And then we have lints, which is a something that could, you know, cause a warning or error. And there are descriptions, there's a name, the severity, and whether or not it can be overridden. I think we're going to want to do something so that we can translate it into different languages. I'm taking inspiration from the Rust compiler, and I know that they're planning on adding this, and I've looked and there's already some work being done there, so I think it will be a later thing. I want to see how they go about it, but I think it would be cool to provide some translations functionality. And then we have reports. A report is something that the compiler emits, and it, has a reference to the lints that caused it, as well as the part of code that caused it. And then diagnostics are things like notes and help messages and stuff like that. And then we have span, which is, some span of text in a file. And we have multi-span, which is a collection of spans. And then diagnostic class, this might not be entirely necessary. So, but there are help diagnostics and note diagnostics, and of course something could be neither of those. And then as an option, you can have the diagnostic point to some code, and then it can also have a label. And then I have a little helper function for if you just want to use a static string as a diagnostic. I'm doing this a little bit differently than the other videos. Instead of like showing you myself coding, I'm just writing the code ahead of the video and then recording an explanation of what I did. So we have this passes function, which is going to return all of the early lengths. So I should explain what early lengths are. It's different from the idea of an early lint in Rust. In Rust, an early lint runs once you have already tokenized the code and parsed it into a syntax tree. But here, it's literally just you're working with characters. So you have this early lint pass tray, and that defines a lint, and you can check each character or you can check an entire file if you would like. So we have passes, and right now there is one early lint, which is the Greek question mark lint, and I'll talk about that more a bit later. And then this lint function, it just runs all of the lints by calling the passes function and running the pass on every file and on every character. And then it returns a list of reports that were given to this early context. The early context itself, it has a report buffer that is under a mutex. My thinking is that in the future, if I want to have this run concurrently for faster compilation, then it would be very easy to do so, because this add report can now be just take a reference instead of a mutable reference to self. And then for each lint pass, you get the context, so you can add reports to it. You have the C, which is the character that you're looking at, and then the span, which tells you where that character is in the code file. And then for a file, you just get the entire code file, and it's your job to parse it and figure out if you should trigger a warning or an error. So this Greek question mark. So let me switch over to Firefox here to show you what that's about. Okay, so this is a little bit of a joke in programming. So this is the Greek question mark. You may notice that it looks a lot like a semicolon. So you replace all the semicolons in the code with a Greek question mark, and now it says semicolon expected, illegal character, semicolon. So basically the idea here is, let me switch back for a second. Um, if it sees a Greek question mark, it suggests that it should be changed out for a semicolon. So basically the check, it uses checkcar. Maybe it could use check file to check for if it's inside a string or something, or maybe in the comments. That would be very helpful. In fact, you could envision this being moved until after tokenization is done in order to give more context. So that makes this this makes this lint and the idea of early lints in general seem extremely um, pointless, but you know, if you want it, there it is. So if it sees a Greek question mark, first of all, it gets the span and it converts it into multi-span. As you can see here, impl from span for multi-span, so you can convert from spans into multi-spans. It has a report and it gives the lint and then the span that caused the lint. Report add diagnostic, so it adds a note. Try using a semicolon, or maybe if you meant to use a Greek question mark, use that, because we might as well have that if you're in a string, but that's not very helpful for comments, which is again why I think it would be cool to have some context, or if it's in a comment or a string, or it somehow found its way into code. Or maybe you try to use the semicolon to start a comment, which is the Greek question mark to start a comment, which is where this really becomes a problem. And then it adds the report to the context, and since it's immutable reference, that's why the mutex is needed. And yeah, that's all I really had. As for testing, I should set up testing, but right now I think it would be better to set up a driver first, which is something I could have worked on instead of this. But once we get the driver working, I will set up testing for it. And then what else? We need tokenization, which is another thing I should work on that's probably like the very next thing that I'll work on for this. Um, Here you can see this to-do common helpers for possible replacements. Something the Rust compiler has is a command called cargo fix. And basically what it does is it looks at, the errors that you got and it suggests whenever the compiler suggests a replacement, it actually puts that replacement into the code, which is really cool. Um, I think that this would be good to have here. So we'll need to set up special code for that, maybe in as part of the reports or maybe as part of the diagnostic. I haven't really figured that part out yet. Um, but I think in order to make that work, you actually have to have tokenizing set up, which means I'll have to work on tokenizing. So um, the idea is that I don't want to insert static text. Instead, I would like to just set up, I'd like to insert tokens, convert the tokens into a string, and then insert that. And that should probably lead to less problems. But anyway, um, I hope this was interesting, and next video will be probably tokenization. Boo! Alright, goodbye.